Okay, let me just welcome everyone to Honors Algebra 2. In this course, we typically skip Chapter 1 and start right out the gate with Chapter 2 since this is an honors class. I'm expecting the topic in this first section in Chapter 2 to be something that you've heard before and just might need a little refreshed on, and that is this idea of domain and range for functions. Your homework assignment this evening will be Worksheet 2.1a, and we're just going to start out with a few terms here just to make sure that you're comfortable with what some of these vocabulary terms are referring to. Okay, the first one is domain. Okay, when you hear the word domain, that is referring to all of the possible x values for that particular relation. Okay, so domain, those are your x values, whereas range is all the possible y values for that particular relation. Okay. Now, the key here is a lot of these problems are going to ask you whether the relation is a function or not. Okay. The formal definition from a math textbook talks about how each element of your domain, that would be all the x's, is paired up with exactly one element of the range, that's the y. And sometimes when students read that sentence, it's a little confusing to them. And so if we were to kind of put this in very, very simple terms, for something to be a function, the x values are not allowed to repeat themselves, okay? So you can be given relations in lots of different ways. You can see in these examples below here. In this first example, we're given several ordered pairs or points. In the second example, we're also given points, but we're given it in the form of a table. In example C, we're just given points plotted. In example D here, this is called a mapping. We're given the points expressed like this, and we can talk through that here in just a moment. Okay, so one thing I do just want to mention back up here at the top is you're going to be asked to state the domain, state the range, and then state yes or no, whether each of these are functions or not. When you are listing the domain and the range, you always want to list these values from the smallest to the largest. Okay, we always want to order them from least to greatest. Okay, all right, so let's go ahead and start with example A here. You'll notice the directions say to state the domain, state the range, and then determine whether this relation is actually a function or not. And this is where we want to focus on whether we're seeing any of those x values repeat. Okay, the proper way to list the domain is to put a capital D followed by a colon, which I already have for you here, and then you're going to list in between braces the smallest x value with commas in between leading up to the largest x value. So if you were to look at these points and only examine the x values alone, and this is simply a coincidence that these are presented already kind of in order from least to greatest, this is what we would come up with for our domain. Okay, the range, same thing. You're going to put an R with a colon, which I have for you there, and then you're going to list, and these are not in order for you already, the smallest y value followed up to the largest y value. Now here's one thing that you should note. If any of either the domain values or the range values would happen to repeat themselves, for example, you'll notice the smallest y value is a -9, but then we also see a -9 over here, you do not need to write the number -9 twice, okay? Because all you're doing when you're listing the domain or the range is you're just saying these are the possible values that could be, in this case, y value since we're doing the range. So repeating yourself is just extra work here. Okay, so a y value could be -9, a y value could be -7, a y value could be -4, and a y value could be +7. Those are the four possibilities since a -9 kind of repeated twice. Okay, now recall when we say yes or no, whether this is a function, we're only looking to see did any of the x values repeat themselves? And the answer is no. So since the x values did not repeat themselves, we're going to say yes, this is a function. Okay? All right, so you can see here that I've already done example B for you. You can see that I've noted that these got a little bit out of whack here, out of order. They should be, these numbers should be pushed over a little bit. I'm not sure what happened there. But the reason we're saying no, this is not a function is because we've got some repeating x values. This arrow should have been pointing to this. I think it would be here if it was slid over. Okay. All right, so let's go ahead and take a look at example C. Okay, here, if we're going to list the domain, think of we want to list the x values. You want to start all the way on the left side of the x-axis. That's where the smallest x values would reside. Okay, it looks like this point here all the way over here to the left would have an x value of -4. And then you're just going to work your way from left to right, writing down the x value of the points. Now, take note, there is a scenario right here where these x values are repeating themselves with these 2 points. They both have an x value of, looks like -3, but I'm only writing that once. Okay. All right, then we're going to do the same thing with the y values, only when you do the y values, you want to start all the way down at the lowest point and work your way up gradually. Okay. Again, if any of these y values are repeating themselves, there is no need at all for you to write those numbers down twice. Okay. Now, I recall that when I was going through and writing down the domain values, there was this repeated x value at -3. That's going to be an indication that I'm going to say, no, this is not a function because the x values, specifically the -3, repeated. Okay. All right, so then that kind of brings us to this idea of the vertical line test. I'll just mention over here with this mapping, and again, these numbers here should have been pushed to the right. This is just another way to represent points. You can see off to the side, I kind of wrote out what those points were. It makes writing the domain and range and identifying whether it's a function or not a little easier. This is saying the x value of -3 gets paired with a y value of 0, so that makes the point -3, 0. Okay, and then same thing, -2 paired with +2. I just wrote them out here. Since the 8 really wasn't paired with anything, because this arrow is going to the 6, as is this arrow here. So you can see we've got some y values repeating, but I don't think we have any of the x values repeating. That's why we're saying that this is a function. And I'm not really actually including the 8 in the range because it really didn't show up in any of the points. Okay. But coming back to example C, this kind of leads into something that we call the vertical line test. You'll notice those 2 points that were in line vertically on the graph. If 2 points are in line vertically, they're going to have the exact same x value. And we know that if 2 points have the exact same x value, well, then that particular relation is not going to qualify as being a function. Okay, and so we have here that we're using the vertical line test. It's used to test whether a given graph is a function or not. That means if it is possible anywhere on your graph to draw a vertical line that would go through the graph in more than 1 point, that disqualifies that graph from being a function. And so you can see here in this example, I think we're pretty safe that there's not a vertical line that we could draw that would pass through this parabola here. In more than 1 point. So we're going to say that passes the vertical line test, so we're saying yes, it's a function. But if we were to flip that parabola over on its side, you can see there are multiple places where if I were to draw a vertical line, then I'm talking about having 2 points in line vertically, and so those x values are definitely going to repeat themselves. Okay, so that's where I'm saying no, this is not a function. Okay, okay, moving on down to the next page here. There are 2 different types of relations. We call one discrete, and the other one is continuous. Okay? Here's the difference between a discrete graph and a continuous graph. A discrete graph is really just a scatter plot. It's just a series of individual points separated. Okay? A continuous graph is when your graph consists of smooth curves or lines that could be drawn without lifting your pencil. An example might be something that looks like this. You can see I'm obviously not lifting my pencil up and creating any gap at all. We call that a continuous graph. Okay. All right. So On this next example 3 here, it says the graph represents the length of the Tour de France in kilometers from the year 2000 to the year 2009. It wants just to know, is that graph discrete or continuous? Well, if I were going to sketch this graph right here, I would be lifting my pencil up off the paper in order to create the next point. It wouldn't be one smooth, continuous graph where these are connected. So I'm going to call this discrete. And then it says, does the graph represent a function? Well, to answer this question, I should apply the vertical line test. Okay, so I'm just going to ask myself, is there any place on this graph where if I drew a vertical line, I would run through more than one point? The answer is no. So I'm going to say, yes, this is a function. All right. I don't know. Looks like my pen stopped working here. All right, hang on one second here. Okay, I apologize about that. All right. Well, example 4, I kind of walked through that one a little bit for you. Again, I don't know why some of this is a little off kilter here. The domain would be these years from 2004 to 2009. Okay, I'm going to jump on down to these last 2 examples, which again seem like they're a little bit out of whack here. These last 2 examples, it's asking you for the to state the domain and the range, and then determine whether it is a function, and then whether it's discrete or continuous. And I'm just going to recopy down the equation here since it's kind of over top of those words a little bit. Okay, so when you graph lines, if you recall from Algebra 1, slope-intercept form is y equals mx plus b. Our y-intercept would be the -3. That's where we would want to start. So we would come over at -3. The coefficient of the x, that is the slope. So we would start with our pencil at the y-intercept -3, and then we would, slope is always rise over run, so we would rise up 1 unit, and then we would run to the right 2 units to drop another point on this line. Okay, if the slope was -1/2, you could rise up 1 unit, but then you would go to the left 2. Okay, I'm just going to go up 1 over 2 a few times here to create several points here. Now I have my line. Okay, so as far as the domain goes, okay, the domain is all the possible x values. And as I look at this graph, I notice that this graph continues in the direction to the left forever and to the right forever. There's no gaps, there are no holes. So it kind of feels like if this line goes forever to the left and forever to the right, then my domain, all the possible x values, would be all the real numbers, like every single possible number. And so the symbol we use in math is this weird looking capital R that kind of feels like it has like an extra left side to it. Okay, I can make the same argument for the range. Okay, the range, again, this line goes down forever and up forever, so it would include all real numbers for the range. Okay, so I've determined the domain and range. I want to use the vertical line test to say whether this is a function. It certainly looks like this would pass the vertical line test, so I'm going to say yes, it is a function, and then it wants to know whether this is continuous or discrete. I'm definitely calling this continuous. There are no holes or gaps at all in this graph. Okay, the next one, we'll just go through this one very quickly here. I'm going to recopy this down. Okay, what I would encourage you to do for this is to go to your calculator. I would encourage you to type in x squared plus 1 on your calculator and then press second, and it's actually the window button gets you into where table setup is. Okay, and you could start the table out at maybe x equals -2. Okay. Then you go into the table by hitting second graph, and this will give you all kinds of points that lie on this particular line. Okay, what makes this equation different than the one we just did? This is a quadratic, it's going to be a parabola. This one here is just a linear equation. Okay, if you were to go into your graph, or into that table rather on your calculator, you would see all kinds of points that you could plot. Okay, and so you can plot several of those here and kind of run your pencil through to sort of get the idea of how the parabola would look. The domain for this, Again, this parabola looks like it is going in the direction to the left forever and to the right forever. It's just going to take a while for it to widen and get there, but it is going to the left and right forever. Okay, the range is all the y values starting at 0 and getting bigger, okay? And that's starting down here at 0, and then it rises up from there. Okay, last couple problems we'll just take a quick peek at here is how to kind of simplify expressions like f of 2y, f of 4a. Here's what they're wanting you to do. You can see up here, they give you the equation for f of x. F of 2y is asking you for every place you see an x in the equation, which is right here where the x squared is, we are supposed to substitute a 2y in its place. Okay? Order of operation says we always do exponents first, so a 2y squared becomes a 4y squared. Then we multiply the 2 and the 4 together, and we discover that f of 2y equals 8y squared minus 8. Okay? If we were to do a similar problem, only this time we're going to substitute a 4a in for all the x's. Again, we're going to do the exponent first, and then we will multiply 2 times 16, and we get f of 4a is 32, a squared minus 8. Okay? That brings this lesson to a close. You will do worksheet 2.1a for your homework then.